As per the Kirchhoff current law, the current meeting at a junction, for example, this node or the junction where the number of currents are meeting towards the junction and outgoing from or away from the junction. For example, current I1, current I2 and current I5 are coming toward the junction or the node. At the same time, the current I3 and I4 are away from the junctions. Hence, take the total summation I, and that will be total summation I is equal to 0 means I take the incoming current or the current coming towards the junction as a positive, means you have to take the current I1 as a positive, current I2 as a positive, similarly current I5 as a positive, and express the summation I, and the current away from the node take as a negative. So current I1 positive, I2 as a positive because they are both current are coming toward the junction. Current I3 take as a minus because it is away from the junction. Take minus I4 plus I5 because current I5 is coming toward the junction is equal to 0. And by solving this, we get one equation: I1 plus I5, I2 plus I5 is equal to I3 plus I4, means incoming current is equal to outgoing current. Now we are going to see the particular problem on it. During that, we are going to solve the particular problem by using KCL, and the KCL method is also known as the nodal analysis. What is that nodal analysis? Nodal analysis means it is a particular method to find out the current flowing in each branch through applying Kirchhoff current law. Now the particular circuit is shown. Now this is carefully. There are two voltage sources are there. First voltage source as a V1 is a 10 volt supply is given. Another voltage source is a V2 as a 15 volt voltage source is given. And one circuit is completed with combination of resistor R1, resistor R2, resistor R3. Now what is that VA, VB, VC? Now due to the supply source 10 volt, a particular current will flow in a particular path. That current is nothing but the current flowing from positive terminal of the battery to the negative terminal of the battery with completing a closed path. And we are going to indicate that current flowing due to only the 10 volt, that is nothing but the current I1. Similarly, take the another voltage source V2. During that V2, the current will similarly fall or current continuously flow from positive terminal of the battery to the negative terminal, means the current I2 will complete one path from positive terminal of the battery to the negative due to the supply voltage V2 or the given voltage rating of 15 volt. Due to that voltage, the current I2 will going to be flow. Now what is that VA, VB, VC? These are also known as the node or junction. What is that node? Nodes mean two or more electric branches meeting at a common point. In this voltage V1, that is 10 volt, one point is connected to the one point, another point is resistor R1, one common point is there, means this is the node A. Similarly for node B, the resistor R1, resistor R2, resistor R3, three resistors are connected with one common point, that is node B. And lastly the node C. What is that node C? C means also having the combination of electric component. This component will be resistor, inductor, fuse, ammeter, voltmeter. Any electrical component are connected with another electrical component and it will form one node. Means there are three nodes are in the circuit. But we can't be say the lower side of this negative side as a node, because one electric source is there or electric element is there, but there is no any element, means there will be no node will be as a node C or D. Similarly only R3 is there, but another both side there is no any electric component, and they will also not known as a node. Similarly for voltage V2, there is no another component is connected with this common point, means in a given circuit only three nodes are presented, and their nodes are node A, node B and the node C. But what is that VA? This VA indicate that voltage across node A, voltage across node B, and the voltage across node C. Now, when are going to solve such types of problems, the problems in engineering level or polytechnic level, the question will be asked as find out the each current or the branch current. This is also known as the branch current because individually R1 is one branch, R2 is another branch, R3 is another branch. The question may be asked find out the branch current, or maybe question asks find out the individual current flowing in R1, R2 or R3. Now for example we are going to see the find out the current in resistor R3 using KCL or nodal analysis. Means the current flowing through R3 is nothing but I3 we are going to be find out by using Kirchhoff current law or nodal analysis. Nodal analysis is nothing but it is a principle by using Kirchhoff current law and finding the specific branch current. Okay, so before solving this current we must start with the node because we are going to find out the current flowing through resistor R3 means we are going to find out the current I3, and this current I3 is incoming current and outgoing. So we are going to take the node VB. If they ask find out the current R1 or current flowing through R1, that is I1, then you have to take the resistor or the node VA and the resistor combination. Means the preference of node will be depend on the which current we are going to find out. Now as per the given problem, find out the current in R3 means we are going to concentrate on this node's particular node B, and the voltage across node B is nothing but VB. So solving this problem, firstly we are going to see how to solve this problem. Okay, so firstly now apply KCL at node B. Means we are going to apply the Kirchhoff current law in node B. Now before applying this Kirchhoff current law across the node B, just observe that according to the current node B we are going to find out the number of current coming towards the node and number of currents away from the nodes. So as per the diagram, due to this voltage source current I1 flowing in a own path, due to this another supply the current I2 is going to in a own path. Means two current I1 and I2 coming toward the junction and current I3 is away from the junctions. Means applying KCL at node B we can write summation I is equal to 0. We can write summation I is equal to 0. Summation I means at node B we are going to observe at node B means observe the current coming towards the node B and away from the nodes B. Means we can take the equation current I1 as a positive because this current I1 coming towards the junction, means current going towards or coming toward the junction as a positive, away from the junction as a negative. Means that is total summation I is nothing but I1 plus I2 minus I3 is equal to 0. That is I1 plus I2 is equal to I3. This equation shows that incoming current is equal to outgoing. Means at the node VB there are three currents are there. Current I1, I2 are incoming current and the outgoing current is I3. And if the addition of this I1 plus I2 will match which practically value with current I3, then the Kirchhoff current law will going to be proved. Okay, so now we are going to solve these particular equations because we are going to concentrate on the node VB because all the current coming and away from this junction, and specially ask the question to find out the current in resistor R3. So we can represent this current I1. Now this current I1 is flowing from which node to which node? Due to this supply V1, the current flowing from node VA to node VB, this current I1 is going to expand with a writing one equation. It means that we can represent the current I1 as VA minus VB divided by resistor R1. Why I am writing like this? Because this particular current I1 is nothing but the current flowing from which node to which node, because the current start from positive terminal battery to the negative terminal battery. Hence take VA minus VB, don't take VB minus VA. Okay, similarly plus you have to also expand the current I2. Similarly we can write one equation for current I2. I2 current flowing due to this positive terminal of the battery, means you have to take the equation like a VC minus VB. The next equation will be VC minus VB divided by resistor R2 is equal to, now we are going to represent similar the current I3. Now this current I3 is nothing but, this is not a particular current flowing due to the supply. Hence this current is showing only due to this node VB, means both are the incoming current and this is the current I3. But as per the Ohm's law, we are going to find out the current. Current I is equal to V by R. Hence we can represent like node VB divided by R3. Why I am going to take like that? Because there is no particular supplies given to flow the current. Hence we can write the equation like current I is equal to V by R, means VB by R3. And in this way we can represent a particular equation to solve the nodal analysis or Kirchhoff current law. Okay, now we have to observe that VA minus VB, we know the value of particular resistor R1, R2 and R3. By keeping the values we can find out the total current, that is we can calculate the current I1, I2 and I3. So firstly the VA voltage is connected across the node VA. 10 volt is applied across the node VA, means I can represent the equation like VA is nothing but 10 minus VB divided by resistor value. Suppose we are going to take the resistor value 2 ohm, 3 ohm and 4 ohm. Suppose we are going to take the particular value of resistor 2 ohm, 3 ohm and 4 ohm. So V is nothing but the voltage across, connected across the 10 volt. Hence represent like a VA minus VB is equal to 10 minus VB divided by the resistance value we are going to take like a 2 ohm. Hence take the 2 in the equation. Similarly take VC. What is that VC? VC, the connected voltage is 15. Hence you have to write 15 minus VB divided by, now we are going to calculate the value of resistance, that is 3 ohm is equal to VB by R3, means VB, we don't know the VB value, VB divided by R3, and we are going to take the value of R3 is nothing but 4. In this way, firstly we are going to find that the current I1 plus I2 is equal to I3. Expand it with the node VA minus VB divided by R1 plus VC minus VB divided by R2 is equal to VB by R3. It means that we don't know the particular value of VB, but we can solve and we can find out the node voltage across B, or the VB is nothing but the voltage across node B. So solve this by solving this particular equation, we can easily find out the VB and then we can calculate the current.